Alright, back to systems of linear equations. There are three ways, once again, to solve. You could solve by graphing, where you graph each equation and see where they cross, and that's your solution. You could use substitution, as we've looked at in the last lesson, where you take one equation and plug it into the second, so you can solve for one equation. Or the idea here is elimination. Please notice this is perfectly set up for an elimination type problem, being I don't have a single variable by itself, and I do have one variable, x, with opposite coefficients, positive 6 and negative 6. The idea here is I'm going to add my two equations together. I'm just simply going to add them straight down. 6x minus 6x is 0 x's. I've eliminated the x's. There's no more of them. And that's where this method gets its name of elimination. That's gone. Negative 6y minus 5y gives you negative 11y equals, add the right side as well. 18 minus 18 is 0. At this point, you can see I'm down to one equation with one variable. All I've got to do is solve. Divide both sides by negative 11. Y is 0. So we're back to the idea that we came up with for substitution. I've got half of the answer. All I have to do is plug this one into either of my two original equations. Remember, this point is on both lines, so it doesn't matter which one I choose. Let's plug it back into the first. So that equation was 6x minus 6 times y, which we know is 0, equals 18. And we'll finish solving. 6 times 0 is 0. That entire term is gone. Leaves me with 6x equals 18. Divide both sides by 6. X is 3. And we now have both pieces to the coordinate that we're looking for. The place where these two lines intersect is located at 3, 0. You can plug in 3 to both equations. They'll both give you the y value of 0 as well. And that's elimination. One more time. You basically want to have the same coefficient for one variable, so when you add them, that variable will be eliminated, leaving you with a much smaller problem to solve.